Have you ever wondered what would actually happen if we just never slept? I know, it sounds like some wild hypothetical scenario, maybe the plot of a sci-fi thriller, right? But the reality of extreme sleep deprivation is absolutely terrifying. If you're revising for your Edexcel GCSE psychology exams, grasping the sheer physical necessity of sleep is literally the best place to start. It really raises the stakes. We aren't just talking about feeling a bit groggy during first period here. We are talking about a fundamental breakdown of the human brain. The grim reality of the research shows that without REM sleep for a prolonged period, and we're talking about just 2 weeks here, you'd experience severe disorientation, massive memory difficulties, illusions, and even intense paranoia. And in laboratory studies, rats that were kept awake for prolonged periods actually died. Just 2 weeks to fatal systemic failure. This is exactly why our brains have evolved such powerful overriding drives to completely shut us down each night. So, welcome to this explainer. I am so incredibly pumped to guide you through this material today. We're going to tackle this syllabus by taking a sort of medical detective approach. We're opening up the diagnostic case files on 2 major psychological sleep disorders, insomnia and narcolepsy. By the end of this, you are going to have these case files completely memorized for your exams. Okay, let's dive right in. Here's our case file agenda for today. We'll start with the importance of sleep, classify primary versus secondary disorders, and then break down the symptoms, risks, causes, and treatments for both insomnia and narcolepsy. First up, the importance of sleep and why we absolutely need to shut down. And moving straight into Section 2, primary versus secondary disorders, basically how we go about classifying the issue. Let's create a perfect mental split for your exam notes right off the bat. First, we have primary sleep disorders. Now, these are problems in and of themselves, entirely unrelated to any other underlying issue. So examples would be an inherent biological problem with going to sleep, staying asleep, or waking up. Contrast that with secondary sleep disorders. These stem from another problem entirely. For instance, if someone is kept awake because they're in physical pain, or they have severe jet lag, or maybe intense stress is wrecking their sleep patterns, that's a secondary disorder. It's absolutely crucial to know this difference before a doctor can accurately diagnose a patient. All right, let's crack open Case File 1, Insomnia, looking at its symptoms and risks. Now, insomnia isn't just about feeling a bit tired the next day. The sheer physical and psychological toll is massive. Physically, you're looking at a weakened immune system, an increased sensitivity to pain, high blood pressure, and even heart disease. Psychologically, it spikes the risk of depression, anxiety, deep confusion, and profound frustration. It impacts your memory, your judgment, your performance at school, and dramatically increases your risk of having an accident. In fact, chronic insomnia can literally shorten your life expectancy. Let me give you a really solid exam anchor right here. Jot down the name Cappuccio from 2010. Cappuccio analyzed 16 different studies looking at longitudinal data of over 1 million participants. What he found was that sleeping less increased the risk for death by 12% compared to those who slept a normal 7 to 8 hours a night. But wait, the danger builds even further. Contrast that 12% with a more recent study by Parthasarathi et al. In 2014. They looked at the effects of persistent insomnia over a massive 38-year longitudinal period. And they found that those with persistent insomnia faced a staggering 98% increased risk of death. Yeah, let that sink in for a second. Which brings us to Section 4, Insomnia Causes and Treatments. How do we actually solve this sleep crisis? Let's take a biological deep dive into the treatments. Traditionally, doctors prescribed sleeping pills that acted as heavy sedatives. These target the brain's GABA receptors, which are normally responsible for alertness, by basically forcing them to cause drowsiness. It essentially acts as a forced switch-off button for your brain. But there's a catch, and it's a big one. Side effects include memory disturbances and a huge risk of physical dependency. Now, contrast that with a newer class of drug called Ramelteon. Instead of forcing the brain off via GABA, it selectively binds to melatonin receptors in the suprachiasmatic nucleus, or SCN for your exam notes. It only acts on the specific area of the brain responsible for circadian rhythms. The results? Far fewer side effects, and it's not thought to be addictive at all. Okay, let's close that file and open up Case File 2, Narcolepsy, Symptoms and Biology. The really crucial point here is the biological disruption happening inside the brain. In a normal sleep cycle, a person spends time in non-REM deep sleep first. It's a gradual descent. But the narcoleptic sleep cycle is fundamentally disturbed. Instead of that gradual descent, patients drop directly into the REM phase shortly after falling asleep. Because of this strange REM intrusion, we see a stack of very specific, highly interconnected symptoms. First, there's excessive daytime drowsiness, feeling intensely sleepy and having a really hard time concentrating. Then, the signature symptom, sudden sleep attacks, where the patient falls asleep instantly and completely without warning during the day. They might also suffer from sleep paralysis, which is a terrifying temporary inability to move or speak when waking up or falling asleep. And finally, cataplexy. I want you to mentally highlight this specific definition for your exams. Cataplexy is a spontaneous and temporary loss of muscle control, usually lasting just a few seconds, resulting in weakness and possible total physical collapse. What's absolutely fascinating, and frankly quite dangerous, is that this collapse is often triggered by strong emotions like laughter or anger. Imagine telling a really funny joke to a friend and they suddenly physically collapse onto the floor. That is the everyday reality of cataplexy. So why does this actually happen? Well, it largely comes down to a brain chemical called hypocretin, which regulates our wakefulness. Patients who suffer from narcolepsy with cataplexy seem to have a distinct lack of this chemical. However, and this is a fantastic nuance to throw into your revision answers, patients who do not suffer from cataplexy, known as type 2 narcolepsy, actually have completely normal levels of hypocretin. So hypocretin doesn't explain all cases, and the exact root cause of the problem is often frustratingly unclear to doctors. Moving to our final section, narcolepsy triggers and management, or living with the waking dream. This brilliantly illustrates just how incredibly complex the brain really is, because the triggers for narcolepsy are bizarrely diverse. It could be hormonal changes during puberty or menopause. It could be triggered by major psychological stress. But surprisingly, it can also be triggered by an infection, like swine flu, or even the medication used to vaccinate against it. The potential triggers are just all over the place. Because we still don't fully understand the root cause, narcolepsy is a disorder that is managed rather than totally cured. If the symptoms are mild, it can sometimes be managed with a strictly controlled, excellent bedtime routine. But for severe symptoms, doctors have to turn to medication. Interestingly, they often prescribe antidepressants. Even though they aren't designed for narcolepsy, they tweak brain chemistry, like serotonin levels, to encourage proper sleep at night. Then, they'll prescribe heavy stimulants to help the patient stay awake during the day. But again, these drugs come with a heavy toll, side effects like nausea, headaches, heart disease, and anxiety. Which brings us to the end of our diagnostic journey today, and leaves us with a pretty provocative final thought. We've seen that through drugs like GABA activators and heavy stimulants, we know exactly how to force the brain to sleep and how to force it to stay awake. But given the severe side effects we just talked about, and the lack of total understanding of chemicals like hypocretin, are we actually any closer to finding a true underlying cure for either insomnia or narcolepsy? As you wrap up your psychology revision, it's a profound reminder of both how far medical science has come and just how much of the human brain remains a total mystery. Good luck with your studies, and keep asking those big questions.